Hey everyone, I'm Dan, and in this video I'll be showing you how to employ vector embeddings to build a music recommendation system. Now, we should all be familiar with algorithmic recommendations. Not necessarily the nuts and bolts of the code, but certainly the experience and being recommended content through your favorite streaming services or online shopping sites or even gaming platforms. So it's my hope that the things that I cover today won't be a huge learning curve. Now, if you'd like to follow along, then great. We will just need to complete a couple of steps to get you started. The first is to sign up for your free KDB.ai cloud instance. It's super simple, it doesn't require a credit card, and will have enough capacity for you to run through all of our demos and even some of your own. Once done, go ahead and grab your endpoint URL and API key and add them into Notepad or your OS equivalent for use later in this demo. Finally, head over to the KDB.ai Learning Hub and pull down the music recommendation notebook from GitHub, ensuring that you complete all of the prerequisites listed in the repo. Great! So with that, let's switch over to our notebook and import the packages that we're going to need for the demo. To do so, I'll select the first code cell, then hold Shift and Enter to execute through them sequentially. We'll also change the column width in our pandas data frame so that we can display our embeddings and music data more prominently on screen. Perfect. So the song data that we'll be using today comes from an open source Spotify dataset hosted on Kaggle. The file in question contains 170,000 songs across multiple genres and dates from 1921 to 2020. Now, the metadata includes things like the song name, the artist, and year, alongside features such as popularity, tempo, loudness, and energy. So with that, let's load the data from the CSV file into a pandas data frame and output to screen. As you can see, we have a little over 170,000 entries split across 19 columns, some of which we probably won't need, so we'll go ahead and tidy this up with a few simple commands. Perfect. So with our new output, we've removed the ID and release date columns. We've formatted our headings with a prefix and consolidated the song artist for each track into a comma-separated string. We've also created a new column that specifies the song and artist name and cleared any duplicates and erroneous entries. The result is a cleaner file which puts us into a great position to build our vector embeddings. Now, with this particular data set, we have a mix of numeric and categorical columns, and we need to accommodate for both. To do so, we'll create an embedding for each type and then concatenate them into a final 30-dimensional embedding that we can store into KDB.ai. To begin, we will work on the categorical embeddings, using our newly created description column and splitting each value into a list of tokens that represent a unique part of the sentence. For example, if I take a line from the famous Christmas song, Let It Snow by Dean Martin, the sentence, oh, the weather outside is frightful, would be broken down into a series of separate tokens. So, oh, the weather outside is frightful, which of course then makes it much easier for algorithms to understand and analyze. Now, the algorithm used in this case is Word2Vec, and it's part of a family of model architectures used to learn word embeddings and downstream into NLP tasks. Once ran, we can see that the result is around 157,000 embeddings, each of which contain 15 dimensions. Now, things are a little easier for our numerical values. They just need to be normalized and then have their mean and standard deviation values set. Again, producing another 15 embeddings. So this leaves us with the task of concatenating our embeddings and creating a new data frame to visualize the output. As you can see, the results are 4 columns that display the name, artist, year, and our newly combined 30-dimensional embeddings. Perfect. So look, let's just take a time out here. I know that this is very new and a fluid space, and I appreciate that there's lots of new information to take into account. Please rest assured that we have created a ton of articles, videos, and demos over on the KDB.ai Learning Hub, and also have a dedicated Slack channel to answer any questions or concerns. Bottom line, we're in this together and we want you to succeed. Anyway, let's get this stored into KDB.ai. To do so, you're going to need your endpoint and API key that you captured earlier. So let's go ahead and get them added now. Next, we will define our table schema in which we will store our embeddings. Again, we're looking for 4 columns here: the name, artist, year, and the embeddings themselves. Also, pay attention to the index types and the similarity measure being used. In this instance, we're using a flat index that doesn't use any pre-trained clusters or modifications. We're also using Euclidean distance, which is effectively the straight line distance between 2 vector points. Now, a quick check of our data, we can see that it comes in at about 80 megabytes. So let's go ahead and chunk that into smaller values of around 10,000 rows at a time. Finally, let's verify that our data has been inserted by running a simple query, which, as you can see, returns around 157,000 values across 4 columns. Okay, great. Let's put this to the test. To begin, I'll search for Dean Martin, which, as you can see, returns over 400 results. Next, I'll filter down and search for Let It Snow, which again returns our track, artist, year, and our embeddings. Now, if I grab those embeddings and perform a similarity search within KDB.ai, you can see that similar results are returned. And again, this is collated from both the numeric and categorical data that we embedded earlier. So let's try this again, but this time automate the process. To do so, I'll create a simple function that's more aligned to how this might be used in a productionized environment. This time, we will search for All I Want for Christmas Is You, which, as you can see, not only returns the different versions, but also the songs that closely match each composition. Remember, we've used simple text embeddings here to expedite learning, but with a different transformer model, we could have created embeddings from the audio files themselves. And when we think about this, it then opens up the possibilities for more use cases. I mean, why not podcasts or educational videos or even machine vibrations in the manufacturing industry? To that, we have a whole bunch of samples, articles, and demo videos over on the KDB.ai Learning Hub. You can also subscribe to our YouTube channel where we'll be posting lots more content over the coming weeks. So until next time, thank you.